Welcome to the students of class 12. Students, today we are going to discuss the numerical problems of the third chapter of your NCERT book, that is current electricity. This chapter you have been taught by our respected teachers, but the numerical part I will discuss today. Students, this chapter is conceptually very rich. So mainly there are 15 topics in this chapter. So we will discuss the numerical problems of each and every topic. Numerical problems related to each and every topic. I am not going to solve here the numerical problems of your NCERT book. That you will have to do by your own. I will explain only good problems of each and every topic, and that will help you to solve the NCERT by your own. Students, this is Rajdeepak Orsis and JBS Pihani. Before starting the lecture, please like, share and subscribe our channel. Students, as you are watching, the name of the chapter is current electricity. So students, main role in this chapter is of current, and thereafter we will study electricity, means flow of current in the different circuits. Students, our first topic is electric current. This is our first topic. The numerical problem of this topic we will discuss today. Students, this topic you have been taught in class 10 also, but this again came in the class 12. So let us try to understand it more clearly, more precisely. Students, you have been taught the definition of electric current. Can you tell? How can you tell? Okay, I am going to tell. Flow of charge per unit time. This is the single Stoke definition of electric current. Flow of charge per unit time. Is called electric current. Students, just see, once you see this definition, then I will elaborate. Students, in this definition, few points are missing. Actually, flow of charge per unit time is called electric current. This is the single Stoke definition of the electric current. But this definition is not precise. So let us make it precise. Net flow of charge. Here you add the word net flow of charge per unit time through a cross section. Now this definition is complete. Students, this definition and all those related things you have been taught by our respected teachers. But why I am going to explain it? Because I will take some numerical problems related to this topic, so concept must be clear to you. The definition must be clear to you. That is the reason I am recapitulating this definition again. So keep this definition in your mind, and by keeping this definition in the mind, you will be able to solve the different types of problems related to the topic electric current. Once you see. Students, have you seen? Okay, I am going to erase it. Actually students, some modification I did in the single stroke definition. Why I did so? Let me explain to you. Suppose this is the section of a wire. This is the section of a wire. In time T1 to T2, amount of charge passes through it was Q1 to Q2. So current will pass through this section of wire will be I, that is Q2 minus Q1 upon T2 minus T1, that is delta Q upon delta T. Actually this current will be average current. Students, we may not tell that how much amount of charge has been passed. Just try to understand this or try to appreciate this thing by taking one more example. Suppose students, this is a gate and some person is passing through it. Suppose in time T1 100 persons has been passed, and time T2 300 persons has been passed. So in between time T1 and T2, how much persons has been passed? Means 200 persons has been passed. In the same way, first at time T1, charge Q1 has been passed, at time T2, charge Q2 has been passed. Or in short, if you want to learn this thing, so in time delta T, amount of charge dQ has been passed through this section of the wire, then the average current will be delta Q upon delta T. Because suppose students, we have taken a wristwatch in our hand and we had taken the duration of 1 minute or 1 second. So in 1 second there are many nanoseconds. So that is the reason this is the average value. Students, if we want to write it instantaneous, then this will become dq by dt. Students, this thing you have been taught, only I am recapitulating. This formula you have been taught. Now try to appreciate another formula of electric current. This is a section of wire. Suppose let there are N1 particles. N1 particles having charge Q1 and also let N2 particles having charge Q2. So students, there are N1 particle having charge Q1 and there are N2 particles having charge Q2. suppose this is the section of wire actually I have taken over here, and here the place is not available, so I am redrawing this section of wire. Suppose N1 particle having charge Q1, so this much amount of charge has been passed through this. From here you mention the direction also, that will help you out to understand whole concept clearly. This is left and this one is right. Now another particles having charge Q2 are also going in the same direction. So the net charge flow through flow through this section will be, simply you will add these things, N1 Q1, N2 Q2, and this much amount of charge has been passed through this section of wire in time t, so the current will be I. This will also be average current, students. Now this part I am going to erase. If you want to note it down, then you may note it down, or you may take a screenshot. Once you see, and thereafter I will remove it. Seen? Okay. So students, this N1 Q1 plus N2 Q2 upon T. Students, take another case. This is the case first. Case first. Now take another case, case 2. Case 2. Actually this formula I will use for elaborating the numerical problems. Let me take a chalk. Here you see, students, this is the section of wire, and N1 Q1 amount of charge is passing through this direction. I mean to say this is left to right, so N1 Q1 amount of charge is going through section left to right. In the same way, N2 Q2 amount of charge is passing through this section of wire right to left. So the net charge passing through this section of wire in time t is N1 Q1 minus N2 Q2. So what will be the current? I is equal to N1 Q1 minus N2 Q2 upon T. If they are going in the same direction, students, then here will be plus. If they are going in the opposite direction, then here will be minus. Try to appreciate, try to understand it. I am going to erase it. If you want to see once. Students, suppose Q2 amount of charge is a negative charge. Q2 is negative. Then students, in this formula, put the value of Q2. If some amount of positive charge and some amount of negative charge going in the same direction, then the current will be N1 Q1 minus N2, sorry, here will be plus, but Q2 is, our Q2 is of minus, so the current will be N1 Q1 minus N2 Q2 upon T. Okay. Now put the value of Q2 in this equation. You will get N1 Q1 plus N2 Q2. If opposite charges are going in the opposite direction, then they will add up. See students, here in this formula I am putting the value of Q2, that is minus Q2. So N1 Q1 minus N2 minus Q2 upon T. So here will be plus N1 Q1 plus N2 Q2 upon T. This will be the electric current. For keeping in the mind, students, this formula, only you will have to learn that if same amount of charge passing through the same direction, then that will be add up. If the same amount of charge is passing in the opposite direction, then it will subtract. So let us take some questions in this article. Students, see here, this is the section of wire. This is the question 1. This is the section of a wire. 10 electrons are passing through this in this direction. Means more clearly, if you want to write, then left right you may write. So from left to right 10 electrons are going. And in the same way 10 electrons are going from right to left. Then how much amount of electric current will pass through it? See students, we have read the same charges, if they are passing a cross section of wire in opposite direction, then they will subtract. So in place of N, the formula is N1 Q1 minus N2 Q2 upon T. So put the value of N1, this is 10, this is charge on electron, this is also again 10, this is charge on electron upon T. So this will be cancelled. So your electric current will be 0. So here students, you have seen that flow of charge is taking place, but current is not flowing through this cross section. So the definition, our definition was the flow of charge per unit time was incorrect until we add net flow of charge. So from this section net flow of charge is 0. That is the reason electric current is 0. Now take another example in this topic. Suppose students 10 electrons, now this is the question number 2. Suppose 10 electrons are going from right to left and 10 positons are going from right to left. Students, see here, the charges are opposite and they are going in the opposite direction, then they will add up. This formula we will apply over here. See students, the amount of electric current will be 10 E 10 plus E and again plus 10 E minus upon T. So it will have some value. If you will put the value of time and will put the value of charge on electron and charge on positron, then simply you will get electric current. Students, probably you have heard about positron, but if not, then I am going to tell. Students, positron is an antiparticle of electron. What do I mean by antiparticle? Students, mass of positron is equal to the mass of electron, but charges are opposite. So you can simply ask a question that, sir, what is the difference in between proton and electron? In the same way, actually electron have negative charge and proton have positive charge. So what is the difference between why the proton is not the antiparticle of electron? Actually, student, the mass of proton is 10,000 times more than that of electron, and the mass of the positron is same as that of electron. So same mass, opposite charge means antiparticle. Okay. Now students, this question is for you. 1000 positrons are passing through a section of wire. 10,000 positrons are passing. This is question number 3 and this is for you. Question number 3. 1000 positrons are passing through a section of wire in 1 nanosecond. What will be the current? What will be the current? This is the question, student. This is for you, and the answer of this question you will have to give in the comment section. Nano means 10 to the power minus 9. Now, what will be the charge on positron, that you know, plus 1.6 into 10 to the power minus 19 coulomb. Now this question is very easy to solve. You may solve this question. Let us try to discuss another concept related to electric current. Now students, we are going to take another type of numerical problems, another type of concept of electric current we will apply over here. So try to understand it. If you are given the charge as a function of time, suppose you are given Q is equal to 4TQ plus 3T square plus 5. This is the function of charge. In this function, the charge is dependent directly on the time. So this is the time dependent function of charge. Students, if this charge is given to you and someone asks you a question that how much amount of electric current will pass through a given cross section if this much amount of charge is passing through it, then simply we know that I is equal to dq by dt. Now differentiate this value. directly, students, I am going to do it. 4 into 3t square plus 3 into 2t plus the differentiation of constant term is always 0, so it is 0. So you have got 12t square plus 6t. This is your required current. If this much amount of charge is passing through any cross section, then if this much amount of charge is passing through any cross section, then this much amount of current will pass through it. Students, if you are given this much amount of charge, or charge is given in the form of a function, and someone is asking a question to you that what will be the current, in this way you will find the current. And if time is also given to you, suppose you are given if this much amount of charge is passing through any cross section. Now the question is, what will be the current at t is equal to 2 seconds? This question is asked to you. Simply you put the value of time over here, means t is equal to 2, and you will get the value of current. Suppose this question is asked to you that what will be the current at time t is equal to 2 seconds. So here you put the value 12 into 2 square plus 6 into 2. So simply 12 into 4 plus 6 into 2. 12 4 is 48 plus 12 means 60. 60 ampere of current will pass through any section of wire at time t is equal to 2 seconds. In the same way, if any other type of function is given to you, you will directly differentiate it if the charge is the function of time. Now I am going to take another type of questions that are usually asked for finding the electric current. In Bohr model of hydrogen atom, this is another question. In Bohr model of hydrogen atom, in Bohr model of hydrogen atom, the electron is assumed to rotate in a circular orbit. The electron is assumed to rotate in a circular orbit of radius (5 into 10 to the power minus 11 meter) at a speed of 2.2 into 10 to the power 6 meter per second. What is the current associated with the electron motion? What is the what is the electric current associated with electron motion. This is the question. Now once you read the question, then I will elaborate it. Students, in this question you are given that in Bohr model of hydrogen atom, the electron is assumed to rotate in a circular orbit of radius 5 into 10 to the power minus 11 meter at a speed of 2.2 into 10 to the power 6 meter per second. What is the electric current associated with the electron motion? So now students, in this case, by which way will you find the current? So once if you want to read or write it down, then write it, and now I am going to erase it once you see. In this question you are given a radius that was 5 into 10 to the power minus 11 meter, and velocity of the electron was given to you, that was 2.2 into 10 to the power 6 meter per second. Now current you have to tell. This is our question. See here students, suppose this is the nucleus of hydrogen atom and this is the orbit in which electron is rotating, and radius of this orbit is r. The velocity of electron is suppose v. Then how much time it will take to complete one circle, one rotation? That will be time period. T is equal to 2 pi r upon v. Simply this is nothing but distance is equal to velocity into time. So if any particle is moving along the circular path, then how much distance it will travel? That will be equal to the circumference of the circle, that will be 2 pi r, if r is the radius of the circle. Now student, put the value 2 pi into 5 into 10 to the power minus 11 upon 2.2 into 10 to the power 6 meter per second. This will be the time, and we know that I is equal to Q upon T. Current is equal to charge upon time. So students, what will be the charge on electron? That will be E upon this time period we will put, and on solving this we will get the current. So let us do it. So the current is E upon T, means 2 pi 5 into 10 to the power minus 11 upon 2.2 into 10 to the power 6 meter per second. Students, now in place of E you may write 1.6 into 10 to the power minus 19 coulomb is the value of C. So on solving this, simply you will get 1.12 into 10 to the power minus 3 ampere or 1.12 milliampere. So students, in this type of problems, usually two formulas are applicable. First one is see, I is equal to Q upon T means E upon T. So students, we know that F is equal to 1 upon T, where F is the frequency. So I is equal to E into F. Or more general, if you want to know, then I am rewriting these formulas. If you want to note it down, note it. Then I will tell. Okay, erasing it. In more general way, students, if this type of problem is given to you, suppose in case of any atom, Q amount of charge is rotating around the nucleus on a circular path of radius r, then we know that the time period will be 2 pi r by v. So we know that students, F is equal to 1 upon T, frequency is equal to 1 upon time period. So what will be the frequency? V is equal to 2 pi r. Okay. Now the current is I is equal to Q upon T. So in place of T you may write capital T. So put the value of capital T over here, you will get Q upon 2 pi r upon V, that is QV 2 pi r. This will be the amount of current associated with Q amount of charge. Now students, in another form, see here in this formula, Q is equal to Q into V upon 2 pi r. Students, what is this value? This value is frequency. So Q into F. This formula and which one? This formula. I mean to say, I is equal to Q upon T or I is equal to QF, where F is the frequency. These two formulas will be applicable in this type of questions. Now students, more or less many types of questions we have discussed in this lecture. If some new type of question will come again, then I will again discuss that question in new lecture. Now one other formula is there, students. Let me explain to you. This is the last one, but this type of question will not asked to you in the board examination, but for only knowledge I am going to tell you. May I erase it? Once you see, and then I will erase it. See? Thank you. Students, you have been taught I is equal to integral J dot ds. This formula you have been taught, where J is the current density, as S is the surface element, and I is the amount of current, and this dot is the dot product of current density into area element. Okay, so this integral is not actually a simple integral. This is the surface integral. Suppose you are given the value of J x y I cap is given to you, and the value of Js is also given to you, and this is nothing but xy square I plus yx square j, and the value of here you want to add, then you may write x square y j cap. Students, if you want to solve, you can get the value of j dot s by doing simple dot product, but here the two variables are there, x and y, and x and y. So this integral is not a single integral. This is inherent two integrals. One is for x and one is for y. One is for y. So students, this type of problem will not ask to you in the board examination, because this is out of your syllabus. So simple, you learn this formula only, and definition of current density and all. And one very popular formula I am going to elaborate over here, but the question related to this formula we will discuss in the next video. I is equal to N E A V D. In this formula, actually students, this is the core formula of this chapter. With the help of this formula, you can find all other formulas that we will do in the next lecture. We will solve the numerical problems related to this formula, not in this lecture, in next lecture. Thank you for watching video. Thank you.